Karibu katika kipindi kingine, na leo tutajifunza topiki nyingine inaitwa differentiation. Tulishajifunza topiki ya seti, tumejifunza topiki ya calculator, scientific calculator, na leo tunakwenda kujifunza topiki ya differentiation. Na topiki ya differentiation hapa tutakwenda kujifunza mambo mbalimbali na application za differentiation ambazo zitatusaidia pia kujifunza topic ya integration. Huwezi ukajua integration pasipo kujua differentiation. Sasa differentiation ni nini? Differentiation ni imetokana na neno differ. Difference ni utofauti. Sasa sisi tunapotumia differentiation tutatumia illustration ya curve, na katika curve hiyo tutatafuta slope ya curve. Utaona katika curve hii inaweza ikawa ni curve ya namna yoyote, inaweza ikawa ni curve ambayo ipo katika polynomial form, inamaanisha ina mikunjo zaidi ya moja na sio square, sio perfect square, sio perfect cycle. Haitakuwa perfect cycle, itakuwa ni curve ambayo iko na shape ya design yoyote, lakini tunachagua pointi mbili katika curve hiyo ambao ni point A na point B. Katika point A, katika x axis imepita katika x, na katika y axis imepita katika function of x, right? And B at x axis imepita katika x plus dx, and kwenye y axis imepita katika function of x plus dx, right? Sasa dx ni nini? Dx ni utofauti au difference between this gap here, that is dx, or sometimes we say change of x. That is the difference between point B and point A. That is change of x. And the change of I, utaona hapo ni kutoka from function of x to function of x plus change of x, right? Okay, so in difference, in order to find the slope, we know that the formula of slope is changing y over changing x, right? So we take y of point B minus y of point A, then divide by x of point B divided by x of point A, right? Then divide by x of point B minus x of point A, right? So to get the slope by using differentiation, that is slope is changing y over changing x. So for our differentiation we use this symbol. This is like change of y divided by change of x. So when we find the slope of chord B, you see it is slope of chord B. It is not its slope of, it is like we assume that this curve from point A to point B, it is like a straight line, like this chord here, right? It is tangent to this chord here. Why we assume that? In differentiation, point A and point B, we try to compress them to be as close as I can, in such a way that that change of x is approximately close to 0. You see, that change of x is approximately close to 0. That's why you come to the slope formula that instead of writing change of y divided by change of x, you can write that dy over dx, or derivative of y in respect to x, right? Derivative of y with respect to x. So instead of writing slope, we say change of y over change of x. Change of I ni nini? Change of I, in point B, we'll see our y is function of x plus change of x. And in point A, our y is y, which is function of x. So when we put into the formula, we'll write f of x plus the change of x minus f of x over change of x. Change of x is x of b minus x of a. So x of b is x plus change of x divided by x minus x. So we'll get this, it will be the formula when we minus to x minus x will cancel and will remain with the dx down here. So our formula will go to, this is where derivative come. You see, as d change of x approaching to 0, it means that that is a derivative. We have said that kwamba hii a na hii b as tukijaribu kushrink kucompress kwamba a and b, this point to b is like they intersect, how they close to each other in such a way that change of x will be 0. Change of x inavyozidi kuwa close to 0 ndipo tunapopata derivative of x of y with respect to x. Derivative of y with respect to x, which is equal to, as change of x approaching 0, our function formula, our formula will be like this: f of x plus change of x minus f of x over change of x, right? So instead of writing change of x, we can write h. We can let h to be change of x. So our equation will be dy dx, or derivative of y with respect to x, is limit of h is approaching 0 is function of x plus h minus function of x divided by h. That is our differentiation by the first principle, right? Let us take an example so that we can know how to use the formula. So our example, it says that we have a function of x which is equal to x, right? So if function of x is equal to x, the function of x plus h will be x plus h, because instead of in point where there is x, instead of write x, we write x plus h. So our number or function will be x plus h. So from our formula, we need to find a derivative of function of x, which is f dash. Function of x we put as f dash, that will be derivative of function of x is equal to h is a limit of h is approaching 0. It is not 0, it is approaching 0. So it is function of x plus h minus function of x over h. So instead of writing function of x plus h, we have already have the value which is x plus h. So in point where there is a function of x plus h, we put x plus h minus in point where there is a function of f of x, we put h divided by h. So when we minus x and x will cancel, we remain with h. h over h is 1. So function of x is equal to x, derivative of that function is 1. Derivative of x is 1. So let's go to the derivative of x square, or function of x square. So instead of write function of x plus h is equal to x square, we will write in point where there is x, we substitute x by x plus h. So instead of write x square, we write x plus h square. Then we go to the formula that x, function of x plus h minus function of x over h. Instead of writing function of x plus h, we write x plus h square minus, instead of writing function of x, we write x square over h. Then we expand the formula x plus h, when we expand it, we know by the quadratic equation it will be x squared plus 2xh plus h squared minus x squared. So x squared and x squared will cancel and we will remain with 2xh plus h squared over h, right? We factor out h outside, so we remain with 2x plus h. H and h will cancel and we will remain with 2x plus h. But h is approximately 0. So instead of writing 2x plus h, it will be 2x plus 0 because h is very small, close to 0. It is very minimum, approximately 0, right? So we remain with 2x. So our derivative of this function of x, which is equal to x squared, will be 2x. So when we derive x squared, we'll get, when we find the derivative of x squared, will be 2x. Alright, so let's go to derivative of x cubic. From begin, we have said that for function of x, if is equal to x cubic, when it is written function of x plus h, we substitute that x plus h on the in the function in point where there is x. You see, kwa mfano hapa imeandikwa x cubic, sio? X cubic. So kwenye point ambayo kuna x, we substitute with x plus h. So instead of writing x cubic, tutaandika x plus h cubic. So whenever on the formula, whenever we have x plus h as a function, we will put that x plus h cubic, right? So here, by the formula of derivative, that from the first principle, that f of x plus h minus f of x over h, as h is close to 0 or approaching to 0, instead of writing function of x plus h, we write x plus h cubic minus x cubic, which is function of x. So we divide by h. When we expand this formula, we remain with x cubic plus 3x square h plus 3x h square plus h cubic minus x cubic. So x cubic and x cubic, when we minus, will remain with 3x square h plus 3x h square plus h cubic. So we factor out h outside and then we will remain with 3x square plus 3xh square plus h square. We remain with 3x square plus 3xh plus h square. We factor out h and h will cancel and we remain with 3x square plus 3xh plus h square. But as h is approximately 0, in point where there is h, we assume it is 0, or it is a number very close to 0, right? So we negligent h and we will remain with 3x square.